All right, guys, so I wanted to give you a couple of counting examples. So examples of questions that we could use the counting for that we were talking about in class. So in class, we were talking about combinations and permutations, and hopefully when you were sitting there, you were thinking, this is kind of fun, this is kind of neat, I like finding out how many things that are possible. Or at least you were thinking, oh, this is so much better than induction, that was driving me crazy. Actually, induction is cool, it just kind of is cool in its own way. All right, combinations and permutations, I think, is a little bit easier to kind of get a feel for, how neat it is. The examples that I'm going to start with today come from a game called Text Twist. All right. So if you haven't ever played it before, this is Text Twist. We used to play it in college all the time when we were sitting in our engineering lab and we were supposed to be writing our 30-page papers on whatever we were writing on at the time. We would sit there and play Text Twist while we were waiting for the experiments to go. The idea behind Text Twist is they give you 6 letters. And with those 6 letters, you have to create words. You've got 3-letter words, so there's a whole bunch of them up there. You got 4-letter words right here. You got 5-letter words, and you got 6-letter words. So, if I came up with a 3-letter word, sag, then it would tell me, okay, yes, sag is a word. And the idea is you're trying to get that 6-letter word. If you can get the 6-letter word, you're allowed to go on to the next level. So as I was thinking about this combinations and permutations, this idea came to me. So S-R-A-G-H-I. So we've got S-R-A-G-H-I. So it gives me 6 letters. Now, if I were to take those 6 letters and rearrange them in different permutations, right? How many different possible permutations are there? Okay, so let's see if we can answer that question first. How many different 6-letter words, of course using words loosely because this counts as a quote word. So how many 6-letter words are there? Okay. Now there's a couple of ways you can go about this. One is to say, okay, well, for the first letter there are 6 possibilities. The second letter there are then 5 because there's only 5 letters left. And then after that, the next letter, there's only 4 things left. Now, hopefully you're getting to recognize that this looks a lot like this, right? 6 factorial. And so if we run that through, we end up getting 6 factorial, which is 720. Now, if there are 2 letters that are the same, that's going to completely change everything because we're going to have to then consider the fact that 2 of them are the same. We're not going to worry about that right now. In fact, in this course, we don't have to worry about when it repeats. But if they're all different, there are 720 different possible ways to mix this up. So, when I'm playing my game there, and I can hit twist and it'll mix them up, but I would have to do that approximately 720 times. And once out of those 720, it would give me the actual 6-letter word. Unfortunately, I'm now out of time. So you actually do have to be able to figure out the words. So let's now ask another question. It also asked me 3-letter words. So let's ask how many 3-letter words are there? Okay. And so it's going to take those, and so it's going to tell me, well, SRA is a word, and then it's going to say ARS is a word. Those are different words, right? They're the same letters in a different combination, but same combination, but a different permutation. So we're asking how many 3-letter words. So what we're going to do is we're going to use our NPR, because this is a permutation where we only want a specific number. Okay? So this is going to be NPR. And the N is how many letters there are in total, which will be 6. And then you've got NPR, which you can put straight into your calculator. And then, of course, R will be 3, because we only want 3 letters. All right? And so you can plug that into your calculator, and you can put 6 NPR 3. Or we also learned that there was an equation. You can go 6 factorial over 6 minus 3 factorial, right? Because it was n over n minus r, right? Or you can even say, well, for the first letter, there's 6 possibilities. The second letter, there's only 5. And the third letter, there's only 4. And so let's look at our calculator here, which is half off the screen. And we'll try to move it over. Oh, it's not going to let me move it over. Anyway, you can see most of the screen there. So we'll try each of those. So we can do 6 factorial. Factorial's in math, remember. So we'll go over to probability and go down to 4. So 6 factorial divided by, and then 6 minus 3, of course, would be 3 factorial, number 4. Okay, which gives us an answer of, you can't see it, it's barely off the screen, 120. Or we can go 6 times 5 times 4, right, which also gives us 120. Or we can do the 6 math, probability, NPR, NPR, and then 3. And we get 120 again. And so there are 120 3-letter words. Okay, now let's ask another question. Let's say letter C. Let's say how many 3-letter combinations are there? Right? So let's say that we put all 6 letters in a bag and I draw 3 of them out and I just look at them. There's no specific order. The order doesn't really matter. I'm just going to get 3 tiles, right? 3 letters. So for that, we're now going to use combinations because we need to get rid of the fact that we have different permutations here so that these are both the same combination of A and R and S. And so in that case, we're going to use 6 NCR3. Or you can do the n over n minus r factorial on the bottom. That r factorial is the thing that gets rid of the extra permutations right there. And so if you do that, you will find that there are 20 different combinations of 3 letters that you can end up with. All right, so that's a few examples of how you can use combinations and permutations with the game of text twist. All right, if you want to look at the next one, I'll look at a group of students who are going to a delegation. Ciao.